Hello everyone. Today we are going to talk about one of the approach of transition from IPv4 to IPv6, that is dual stack approach. My name is Suraj Narnolia. Welcome to my video. So why do we need IPv6? IPv4 and IPv6 will exist for a long time. That's the thing. But IPv4 have very less number of addresses than the number of devices available. Today, the number of devices that are using internet is more than the number of human beings on this planet. That's why we need more number of IP addresses, and IPv4 addressing is lacking behind for creating so much addresses. That's why we are using IPv6, and here the IPv4 and IPv6 will coexist for a long time together, and many techniques were developed to handle these transitions smoothly. So we are gonna talk about many type of transition techniques that will transition the IPv4 to IPv6 addressing. These techniques can be summarized into three categories that are dual stack, tunneling, and translation. So in this PPT, we are going to talk about the dual stack approach of transition technique. The introduction of dual stack approach includes that what is a dual stack? A method for IPv4 to IPv6 transition where devices support both protocol stacks simultaneously, ensures interoperability between IPv4 only and IPv6 only devices. A dual stack device supports both IPv4 and IPv6. Such a device can be a PC, a server, or a router. So, uh, why do we really need IPv6? As we discussed earlier, the exhaustion of IPv4 addresses led to uh, discovery of IPv6 addresses, and the growing adoption of IPv6 for scalability and future proofing. So we are gonna see it through example. Here, if a host device need to access the server at example.com, so he will first request the DNS server for the communication with example.com. So here it will ask the local DNS server for all available IP addresses of example.com, that I need IP address of example.com. Here the DNS server will get the request and reply with both IPv6 and IPv4 addresses. Here the IPv6 address will be in the format of AAA, and the IPv4 address will be of type A only. And in the second step, the host chooses the IPv4 and IPv6. So in most cases, IPv6 address is chosen by default. So IPv6 session is established, uh, and this is the last step. But what happens if IPv6 does not work with the server at example.com? The client would experience some delay. The reason is simple, that IPv6 connection failed. The client would try again to establish connection using IPv4, uh, and by this the IPv4 connection will get established, and the client will also be able to access the example.com easily. Here are some use cases of IPv6 and IPv4 transition, that is dual stack approach. The service providers, they serve existing IPv4 customers while expanding with IPv6 capabilities. It is also useful for enterprise networks. Dual stacking Dual stack networking ensures compatibility across mixed environments, and cloud formats such as Kubernetes clusters use dual stack networking for pods and services. In conclusion, the dual stack approach ensures a smooth transitions from IPv4 to IPv6 without disrupting existing services. It is flexible, efficient, and future ready, but requires careful planning due to infrastructure demands. That's it from my side. Thank you for listening. Hope you liked it.